Good morning, everyone. This is Mr. Rowe. We're looking in Geometry Part A. This is a lesson on congruency proofs, and I'm going to show you how to write a paragraph proof from the given information. So when you start a paragraph proof, you got to make sure you understand what you're given. So we've got a couple of givens here. We have that AB is congruent to CD, so those are segments. And what I like to do is, as I see them, I like to come over here to my diagram and I like to mark them. So I'm going to mark AB is congruent to CD. So I'm going to go ahead and mark that. I'm also told that AE is congruent to CF. So I'm going to mark that. And now, what am I trying to prove? I'm trying to prove that the triangle ABF, so A, B, F right here, is congruent to triangle C, E, D. So that's what I'm trying to prove. Now, how am I going to get there? This is where I'm going to start thinking out my process. And what I actually like to do is, if I'm told to do a paragraph proof, I'm going to start off by writing the two-column proof first, because I find that two-column proofs to me are the easiest to do, and then I can take each one of those statements and make a sentence out of it to make my paragraph. So let's take a look. So some other things that I notice here is I have a right triangle. So I have a right angle here. So since these are side by side, I know that that's going to be a right angle. I know that that's going to be a right angle. So those are kind of given things that we know. And so that makes us a right triangle, and this is a right triangle. So my initial thoughts is, how am I going to use hypotenuse leg or something like that to prove that these triangles are congruent? So to use hypotenuse leg, I need to know that the hypotenuses are congruent. And I need to know that a leg is congruent. All right. So I've got the hypotenuse, and I can easily state that because this is a right triangle. I can easily make the statement that this is the hypotenuse of the right triangle. Same thing for this triangle. But now I need a leg. Well, I'm not given that a leg of the triangle is congruent. I'm only given that a piece of one of the legs is congruent. But here's something that I also recognize. I recognize right here that this segment right here, it's shared in both triangles. So I might be able to use this along with the segment addition postulate to show that this segment right here is congruent to this segment. And then if I can do that, that's going to be the leg of my hypotenuse, so I'll be able to use hypotenuse leg. So let's see if we can work our way to that. So when we start a two-column proof, we're going to do some statements and reasons. Okay, so I got my statement, I got my reason. And so I'm going to start off always with a given. So my first given is that AB is congruent to segment CD. That's a given. So I've got that, given with an N. And then I've got that segment AE is congruent to segment CF. So that's also a given. So from here is where I'm going to start thinking about things that I know or that I can show. And then I'm going to start off by trying to get to this segment being congruent to this segment. But to do that, I have to build through the segment addition postulate. So I'm going to start off by making what you might think is an obvious statement, but just remember, in any proof, nothing's obvious. You have to state everything. So I'm going to make the statement that AE, this is the distance AE, has to be equal to the distance CF, and that comes from this statement right here, and that is by definition of congruent segments. And notice I'm using a little short notation there because this is a two-column proof. I'm asked to write a paragraph, so I'm just kind of abbreviating so I can get through this quickly. So now what else do I know? I know this section EF right here, that's shared in both segments that I'm trying to show are congruent. So I can do this step. I can say that AE plus EF has to equal CF plus EF. So basically what I did was I added this section to both sides. Well, how can I do that? Well, since I've added the same thing to both sides, that's by the addition property of equality. So I can add the same number to both sides. Oh, that's a 4 right there, Mr. Rowe. Okay, so we got our first 4 steps. So now, what does this tell me? Right here. Well, I know that AE plus EF has to equal this segment right here, which is AF. Now, how do I know that? That's the segment addition postulate. Same thing for number 6. We're going to state this other section right here. CF plus EF has to equal, and let's move this back down so we can see it right here, has to equal this segment EC, or CE. Yeah, we can see it. And same reason, that's segment addition postulate. And so now how can I use that? Well, I now know that AF right here is the same as this, right? I know that CE right here is the same as this. So now I can make this statement that says AF must equal CE. And how do we know this? There's a couple things that we can say here, but I'm going to say substitution. So this will be the substitution property. Okay. And so now once I have that the distances are the same, well, guess what? I now know that AF, segment AF, is congruent to segment CE. And that's going to be, that's an 8. That's going to be definition again of congruent segments. And 2 segments have the same length and they must be congruent. So you might think we're done here, but we haven't made some other statements. We haven't stated that we have right angles. We have to state right angles in order to be able to use hypotenuse leg, which was what we talked about in the beginning. So we're going to have to make those statements. So what statements do we need to make here? We need to say that angle AFB and segment CED are right angles. So that's going to be a statement we're going to make. Lift this up a little bit. And we're going to use that that's a given. I know some folks might watch this and say, well, that's not given, but yeah, we're writing a paragraph proof, so we're going to make that a given. Okay, number 10. In order to use hypotenuse leg, now that we have a right angle, we can say that triangle ABF and triangle CED are right triangles. And that's by definition of right triangle. And then we have to say that the segment that we're talking about is the hypotenuse. So we've got AB, segment AB is the hypotenuse of triangle ABF, and CD is the hypotenuse of triangle CED, and this is number 11. This is definition of hypotenuse. Hypotenuse is always across from the right angle. And then the final statement is because we have our hypotenuse now, that makes this other segment that we know is congruent now, right here. That makes this the leg. So now we can say that triangle ABF is congruent to triangle CED, and this is by hypotenuse leg. And so now what I'm going to do is I'm going to take this and turn this into a paragraph. So now this becomes my paragraph proof. So I'm pulling a new sheet of paper here and I'm going to write my paragraph. Now you say this might be double the work, but this is kind of like your outline that you would use in an English class for your English paper. So now we're going to turn our rough draft or our thought process into our paragraph. So that's what we're going to do here. So we can kind of abbreviate some things here since we know that, and we're going to use good notation. Segment AB is congruent to segment CD, and let's actually just stop at that, and we'll write that and see how this is kind of a rough draft here. So we know that segment AB is congruent to segment CD, and that's a given. So I mean, we know that, so that's a good statement. We also know that segment AE is congruent to segment CF because of this. We know that AE equals CF by definition of congruent segments. And since EF is the same as EF, we can state that, and you see I'm going right down my list here, AE plus EF equals AF, and CF plus EF equals CE by segment addition postulate. Using substitution, see, I'm trying to get my reasons in there with my statements. Using substitution, we can say that AF equals CE. This means by definition of congruent segments, that segment AF is congruent to segment CE. We are also given that angle AFB and angle CED are right angles. So by definition of right triangle, triangle ABF and triangle CED are right triangles. And see, we're just going right down our list here. Because of the definition of right triangle, or the definition of hypotenuse, I should say, segment AB is the hypotenuse of triangle ABF, and CD is the hypotenuse of triangle CED. Since we have a leg and the hypotenuse congruent, we can say that triangle ABF is congruent to triangle CED by hypotenuse leg theorem. And so that's how you translate that into a paragraph proof. And yes, paragraph proofs can be quite detailed and quite long, so don't think you're going to write 2 sentences and be done. This is going to be kind of a meaty paragraph. Make sure that everything is in there. If you think it's something obvious, go ahead and put it in there, because we want everything in our proof. Nothing is to be assumed. So I hope this helps you write your paragraph proof in this lesson. If you struggle with this as you're working, please let me know through an email or message, and I will help you any way I can.